Hello all, welcome to Embedded Linux Learning Point, a learning platform for anyone who wants to learn Embedded Linux and Internet of Things. In this series of videos, we are building an IoT platform called Sense and Act. In this video, we will look at the elements of Embedded Linux, introduction to toolchains, build and install crosstool-NG. What are the elements of Embedded Linux? So every project begins by obtaining, customizing and developing these four elements. The first element is the toolchain, the compiler and other tools needed to create code for your target device. So this is the main focus of this video. The next element is the bootloader, the program that initializes the board and loads the Linux kernel. The kernel itself, so this is the heart of the system, managing system resources and interfacing with hardware. The fourth one is root file system, contains the libraries and programs that are run once the kernel has completed its initialization. So these are the basic four elements of embedded Linux. There is also a fifth element called our embedded applications. These are some things which will be built later when we have all these four elements in place. Once your embedded board is running with bootloader, kernel and the root file system, on the top of that you will have your embedded applications. So what is a toolchain? A toolchain is a set of tools that compiles source code into executables that can run on your target device. Basically, the toolchain includes compiler, linker, and runtime libraries. So it has to be able to compile code written in assembly, C and C++, since these are the languages used in the base open source packages. So what it means is that your toolchain contains a set of tools for you to convert your source code into an executable binary. So that's what it is. So how do we get toolchains? So usually toolchains for Linux are based on the components from the GNU project. A standard GNU toolchain consists of three main components. One is binutils, a set of binary utils including the assembler and the linker. We can check here for more details of the binutils. As you can see, the GNU binutils are collection of binary tools. The main ones are LD, the GNU linker, AS, the GNU assembler, Gold, a new and faster ELF only linker. So this is basically main tools. Apart from that, there are many other tools that are included which we can use for our purpose. The next thing is GNU compiler collection, which we normally call as GCC. These are the compilers for C and other languages. So if you go here, you can see that GCC, the GNU compiler collection, has support for different programming languages like C, C++, Objective-C, Fortran, Ada, Go and D. The next thing is the C library, a standardized application program interface called APIs based on the POSIX specification, which is the main interface to the operating system kernel for the applications. So this is something which we need in order to build an application to work with the kernel. If we are writing a driver, for example, it should have function calls like the open, close, read and write. So these are which are defined in the POSIX specification, so which we will see when we start writing device drivers. So along with these, we will need a copy of Linux kernel headers which contain definitions and constants that are needed when accessing the kernel directly. So this is something like kernel headers are the doorway to access the Linux kernel. So what are the types of toolchains that we have? There are two types of toolchain. One is native and the other is cross toolchain. The native toolchain runs on the same type of system as the programs it generates. This is the usual case for desktop and servers, and it is becoming popular on certain class of embedded devices where there is a lot of memory available for the toolchain to exist, or toolchain to run within the target. This toolchain runs on a different type of system than the target, allowing the development to be done on a fast desktop PC and then loaded into the embedded target for testing. So this picture tells a little bit more about the cross compiling and the native compiling. With respect to native compiling, if you see, the target is the PC x86 and it runs on the x86 PC where the source code is compiled. The cross compiling, here the source or the host, the compiling machine is x86 and the code is built for the beagleboneblack ARM image. So that is something like you have your source code and the source code is built for a different platform of the target than the host machine where the code is compiled. In some of the embedded devices where there is a lot of memory available, where the toolchain can run. So this is an example where beagleboneblack can have its native toolchain installed and then the source code is compiled for the beagleboneblack itself. This is also an example of native toolchain or native compiling. The toolchain has to be built according to the capabilities of the target CPU. So in our case, if we are building for beagleboneblack, which is what we have chosen for our hardware, the CPU architecture is ARM architecture and the toolchain also should be able to handle the big or the little Indian operation. So for us, it is a little Indian. The floating point support, yes, we need to support a floating point operation. And the application binary interface. So this is the calling convention used for passing parameters between function calls. The ARM architecture transition to extended application binary interface. So we will see if it is needed what the EABI means. So for any toolchain or the toolchain that it generates will have a naming convention. The GNU uses a prefix to the name of each tool in the toolchain. It consists of a tuple of 3 or 4 components separated by dashes. So the first component is a CPU. This is the CPU architecture such as ARM, MIPS or x86-64. So along with that we will have Indianness appended. If it is EL, it is Little Indian, MIPSEL for example. If it is EB, for Big Indian, ARM EB for example. And the second prefix is the vendor. This identifies the provider of the toolchain. Examples include if it is built using the build root, you will have a build root. If it is done with the POKey, you will have to append with the POKey, or the toolchain appends with POKey, or just unknown. Sometimes it is left out altogether. The kernel, for our purpose, it is always a Linux because we are building for Linux. In case if you are building for say BSD, it will be BSD. The operating system, the name of the user space component, which might be a GNU or MUSL. The ABI may be appended here as well. For ARM toolchains, you may see GNU EABI, GNU EAB, IHF and things like that. So this is how the naming convention is. Let's see some examples here. If you want to see the exact naming convention that's used in your GCC, we can go and see something like GCC-dump machine. So it will give us x86-64 and the Linux GNU. So that means the CPU is of x86-64 architecture and the kernel is of Linux type, or the kernel is Linux and the user space is GNU. Similarly, if we do for the cross toolchain, the one which I have is, I'll go to CD, xtools or Cortex ls okay, this is where I have the cross toolchain which I have installed, of course, which I will show you how to build this cross toolchain later. So let's see on Cortex GNU, okay, and the GCC with dump machine. Here you can see that it gave ARM Cortex A8 Linux GNU ABI HF. So that means the CPU is of ARM Cortex A8 type and a kernel of Linux and user space is GNU. Okay, so here the unknown is not there and the vendor completely is omitted out. Okay, so now we know a little bit about the toolchain. Let's build and install the crosstool-NG. The crosstool-NG is a toolchain generator, which is something like it contains a set of scripts and make files. So for us to build and install a crosstool-NG, we need a Linux host. In my case, I have Ubuntu, which I'm using, and we need to install below software to follow along. Okay, so in my case, I have already have these things, but let's see if I can show you. So I'll copy this and then I will go to elpdev environment and where I will build the toolchains. Here if you see I have nothing, so here I will install things that are needed, enter the password. Well, it looks like all of these are already met because I have installed everything before. And the next thing we need is the actual source code for the crosstool-NG that will be available, that is available in this Git repository. So let's clone the repository now. So well, all the commands that I have used documented here in the Git repository. You can also have a look at it. I will leave the link in the description. Then cd to crosstool-NG, and then we will use the 1.224.0 version. So let's check out this branch. Okay, and the git branch, so now it is at this branch, and let's run this bootstrap. So probably it's going to take some time. Okay, while it takes some time to generate some configurations, let's look at more about crosstool-NG. Crosstool-NG is a versatile cross toolchain generator. It supports many architectures and components and has a simple yet powerful menu config style interface. Please read the introduction and refer to the documentation for more information. So as you see, it is not a toolchain, it is a toolchain generator. Okay, let's read through the introduction and understand what it does. Crosstool-NG aims at building toolchains. Toolchains are the essential component in a software development project. It will compile, assemble and link the code that is being developed. So let's wait until it finishes. Well, now the bootstrap is done. Let's run the configure command. If you see this configure and we have prefixed with the pwd, that means we configure the make files to install in the current working directory, the present working directory. Okay, so the configuration is done. Now we will have to run the make command. I think it's also going to take some time. So now it's built. Let's install stall. Let's install it. So as you can see that it's getting installed. So we have instructed to install in the present working directory. during the configuration. Okay, so now it is installed. Let's do an ls and see that it's installed. Then cd to bin. This is where the toolchain generator will be installed. Okay, this is cd-ng. This is going to be the application that we will use to generate the toolchain. Okay, so with this we have installed the toolchain generator called crosstool-NG, and we will use this for generating toolchain for both beagleboneblack and QEMU ARM emulator during the next few episodes. So I hope this is helpful. Thanks for watching.
If this video helped you in learning, please like the video and subscribe to the channel. Also, share with anyone who is interested to learn more about embedded Linux and Internet of Things. Leave a comment below for any feedback or discussion.